Okay, let's have a look at all the sets of the data in this particular mock to see which set should be attempted first and which one should be done later. Okay. As usual, I'll spend about a minute and a half in each set trying to understand what it is all about. Okay. So first set, university residential program has two zones, zone A and B. Each zone has individual houses, floors, blocks, etc. Okay. Residential spaces have addresses which indicate the row and the column in the block plan given below. Rows are numbered 1 to 4 from top to bottom and columns are numbered 1 to 4 from left to right. Okay, that's fine. Now what is it asking me to do? The number of students residing in the 16 spaces in the grid of plan A includes every odd number from 5 to 35, while 16 spaces in grid can be even numbers from 2 to 32. So it will possibly ask me to arrange these numbers into these two grids. Below is a partially filled grid indicating number of students residing in various addresses, zone A and zone B. Now, by and large, this kind of data set I like doing, I can do them, but they are a little time consuming. And then one minor issue with this is, at times there might be a logic which you might miss out on. So from that point of view, typically these kind of data sets, I want to do it, but I classify them as medium, which means I'll do it after I have done at least one other set or maybe two other sets, and then I'll come back and do it. Also, these are 16 plus 16, 32 numbers to be filled up. Yes, about 10 odd numbers have already been filled up, but it is still going to be significant amount of, let's say, working which will be required. Okay, the number of statements is only 4. 4 statements is usually a little insufficient, though the statements appear to be a bit longer, so they might have sufficient information. At this point of time, I am saying this is a medium data set for me. I will look at the questions and the choices and then decide whether I will do it classified as easy or continue with the medium part. Okay, definite answer. Okay, what is the largest number of students? There is a data insufficient, there is a data insufficient, there is a data insufficient. Okay, now what this effectively means is there is a possibility that I may not be able to fill up the table, or there might be multiple cases. Okay, and okay, there is a fifth question also. Okay, so out of the 5 questions, 3 questions have a data insufficient. There is a chance that it might not be fully solvable. So I will come back to it later. This remains a medium data set for me, not my first priority to attempt. Next set of data, lots of information, 6 statements. What is it? 10 online interviews to be scheduled, arrangement data set. Okay, this line clearly tells me for each of the, so there are 10 candidates, 4 okay, they are BTech, BSc, BCom. Each candidate is again B1 to B5. So I'll have to do B1, 2, 3, 4, 5 panels, and then you have these 10 candidates. Okay, these candidates are interviewed. Okay, each interview scheduled in one of the 4 consecutive 1 hour slots from 10 to 2 p.m. Okay, so that means 10 to 11, 11 to 12, 12 to 1, 1 to 2. So B1 to B5 are the panelists. These are the time slots. Now I'll have to fit in people, each of these 10 candidates into this. And then yeah, the information seems to be sufficient. 5 statements only. But please look at the length of the statements. Each statement is 1.5 line. Multiple pieces of information are there. Okay. So 1 piece of information, 2 pieces of information, 3 pieces of information, 4 pieces of information. Long statements, while it is 5 statements only, each statement seems to be having 2 to 3, let's say, pieces of information, and hence it is possible that I will be able to complete the table. But at this point of time, it looks some amount of work. So let me again look at the question and choices to decide whether it is doable now or should I come back to it later. Okay. Which of the following is true? This is fine. For how many candidates can we uniquely determine? Okay, this is telling me possibly there will be cases and we will not be able to complete the table. Which of the following panels conduct N is interviewed by? So there is a definite answer here, but this one says we may not be able to completely fill up the table. Okay. Okay. Again, these two. If panel come, cases will be there, we will not be able to complete. Though I might still do this question saying panel 5 conducts the interview in consecutive slots and then solve it further. Okay. So this is very clearly telling me that the data set is not going to be is something which I'll be able to completely solve. There will be cases, and hence from my point of view, I will come back to it later. Right now, both set number 1 and set number 2 are, was something which I would want to do later. Between the two, my preference will be 1 over 2 because numbers are my strength area. I can play with numbers. So this is what I would want to do. However, if arrangement is your strong area, then this becomes a better set for you. Okay. Third set. Geo Sudoku is a type of, okay, I like this set. Why? Because I have been playing Sudoku for ages. So something which is Sudoku and uses the same rules will be very, very comfortable for me. When instead of letters, some figures are provided. The only rule is each figure should occur on exactly once in each row and each column. The unfinished 6x6 Sudoku board is given. Those are okay, yeah. I will definitely want to do it. Sudoku, as I said, is my strong area. I have been playing it. I played it multiple times. So there is not something which I will have a problem solving. And out of 36, 6, 7, 8, 9, 10, 11, 12, 13, almost half the grid has been filled up. And what about the questions? Definite answers or choices are there? Definite answers in all of them. Which are filled by kings? Which pieces are placed in these? What? Okay, what sequence or whatever. While moving horizontally, definite answers in each of them. Okay. Okay. So should not be a problem at all. This is a data set which I think I can comfortably solve. At this point of time, I'll say this is easy one for me. My order, my preference will be set number 3, followed by set number 1, followed by set number 2. This is my order of attempt at this point of time. What about the next set, 39 to 43? Travel company has operation in 12 locations, T1 to T12, spread in the state of Rajasthan. These 12 towns are vertices of a 12-sided polygon. In order from T1 to T12, each of these locations, one van carrying 10 tourists with a maximum capacity, 10 tourists with which is its maximum capacity, departs in the morning at 8 am. For each of the other locations, returns to the base in the night. Okay. No other trips are scheduled other than the morning and night departures by the travel company. All the vans take the shortest route to the destination. For example, to go to from T3 to T6, you take a road along the diagonal that connects the two of them directly. Okay. So what is it going to ask you? It is going to ask you how many trips are made. Okay, so it's a 12-sided polygon. Now one other thing which we need to remember, a 12-sided polygon. Okay, a 12-sided polygon is almost equal to a circle. Okay, so that is one thing which I will always do. When the number of sides are high, I'll assume it to be a circle, but that may or may not be useful. I am not sure at this point of time. But all I am saying is this is a data set which appears to be more about finding the number of trips from point A to point B. Let's look at the questions. Maximum number of tourists. Okay, number of trips into 10 would be the answer. Okay, again maximum number of tourists that could apply. Again, the number of trips is what we need to find out. So this is a data set which appears to be doable and not too much of calculations. Okay, there is additional data for the next two questions, 4 and 5. Okay. Okay. So I think that also should not be a problem. So at this point of time, my sequence changes again. Set number 3, followed by set number 4, followed by set number 1, and then by set number 2. This is going to be my order of attempt. Okay. My attempt sequence, if I was doing this paper, would be this. Okay. Okay. So please, based on your own strengths and weaknesses, you choose which is the right sequence of attempt for you. Okay, let's have a look at this kind of this particular data set. It says Geo Sudoku, a type of Sudoku game where instead of letters, some figures are provided. Only rule is that each figure should occur exactly once in each row and column. The unfinished 6x Sudoku board is given. Rows are numbered A to F and columns are 1 to 6. Now, this is a kind of data set which I love because Sudoku is something which I can do comfortably. But what I don't like about this is the figures. So instead of figures, I would want to use alphabets or numbers. Okay. So for my ease, I will probably call them king, queen, k, q. Okay, there's a knight also. So let me call them numbers. So I'll call king as 1, queen as 2, bishop as 3, knight as 4, rook as 5, pawn as 6. Okay. So I will first copy this because copying the figure is not going to be easy. So either you use an alphabet or you use a number based on your comfort. Okay. So let me just copy this first. So what I have here is I can see this queen is 1, 2, 3 and 4. So ABC diagonally and E4. ABC diagonally and E4 is queen. So that is 1 or no, queen is 2, sorry. Queen is 2, 2, 2, 2 and E4 is also 2. And what do we have in the king space? Okay, 1 and 1, 2 queens. So A2 and D4, A2 and D4 are kings. A2 and D4 are kings. Okay, then we have pawn A6, C1, A6 and C1. A6, C1 is number 6. A6 and C1 is number 6. A6 and C1, and next to the king also we had a number 6. Next to the king also, yeah. Okay, then we have this knight is 4. 4 is C4. C6 is knight. C6 is 4. C6 is 4. What is the other one? Okay, then D1 is going to be 5. D1 is 5. D1 is 5. This is a little painful, but I think it is important that we do this correctly. Okay, and F5 is 3. F5 is 3. F5 is 3. F5 is 3. Sorry. Okay, and what I have missed? So I think the first row is still pending. So this is going to be 5. This is 3. 5, 3. 4, 5, 3, 4, 6, 5, 3, 4. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 filled up. Let me check up if I missed something. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No, everything has been filled up. Okay. Okay. So I can see queen has come in very often. 4 times queen has come. So I need to fill in only 2 more queens. The number 2, that is. So first column, second column, third column, fourth column, queen has been taken care of. So that means first row is gone, second row is gone, third row is gone, fifth row is gone. So we only need D and F. In both these we need queen. I am going to change the color of my pen now. Okay. Okay, yeah. So queen is required in these 2 and these 2. So that means queen F1 to 4 not possible. 5 is not there. So queen will have to be here. If it is here, that means in D6 queen cannot be there. D5 queen will have to be there. Okay. Anything else? 1 only, twice, 2 ones only, 4 2 5s. Okay, let me look at the question and the choices. Let me start from there. Which cells are filled with kings? B1, B3 are the 2 options here. B1, B3, do they have kings? B1 can have king, B3 can have king. I can't say anything, so I will not eliminate choices based on this. What about C5 and C6 are common to all of them. That means C5 and C6, both of them are kings. So C5 and C6 are kings. That means both of them should be 1. C5 has to be 1. And which was the other number? C5 and E6, if I remember correctly. Yes, E6 is also 1. E6 is also 1. Okay. So 1, 2, 3, 4. So we need a king in B and F. B and F means we can have a king out here. We can have a king out here. Second column not possible. Third column again king possible and king possible. So both are possible. Okay, king is not possible in column 4, 5, 6. They already have. Okay, so we can't say at this point of time for okay. Which of the cells are filled with kings? F2 and F3. Let me see F2 and F3. Do they have kings? F2, F3, both of them cannot have kings. F2 cannot have a king. F3 can have a king. So between F2 and F3, F2 choice is ruled out. So choice 4 and choice 1 are ruled out because F2 cannot be a king. Okay, so B1 and B3, one of them is to be a king. Okay, B1 and B3 is one of them. So F3 is definitely a king, na? So that tells me F3 is definitely a king. So if F3 is a king, that means B3 cannot be a king, but B1 will have to be a king. Yes. Okay. So B1 will be a king, B3 will not be a king. B1 will be a king. Okay. 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 Question 2, question 3. Let me look at question 3 first. Which pieces are placed in E1, D2, C2, D6? E1, C2. E1. Okay. C2. C2. So E1, C2, and the third is D6. D6. Okay. Let me try and fill up a few numbers. I already have 1, 2, 5. In column 1, I already have 1, 2, 5, 6. 1, 2, 5, 6 means I am left with 3 and 4. 3 cannot come here in a column in row F. 3 is not possible here, so 3 will have to come here and 4 will have to come here. So we had E3, E1, sorry. E1 has to be 3 and 3 is bishop. E1 is 3, 3 is bishop. So E1 is going to be 3, which is bishop. Wow, 2 choices gone. So, okay, bishop. So other 2, okay, this also tells me D6 is also a bishop. Very good. D6 is a bishop. So let me put bishop as 3 again in D6 also. So D6 is a bishop, which is number 3. So very good. So I have a 4 out here. So what is the number cell that we need to look at now? We need to look at C2. 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 What will it be? It can be 1, 2, 3 or 5. 3 or 5. Okay. We'll come back to it. We know it is either 3. Oh, this cannot be 3. C4 cannot be 3. This will have to be 5. So this will have to be 3. So C2 has to be 3, which is also a bishop. Great. So bishop, bishop, bishop. 2 questions solved. Third question, okay, rather question number 2. Which cell sequence denote the position of king, queen, bishop, knight, rook and pawn? This is 1 to 6. Okay. 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 So king B1 was a king, which is fine. B1 C5. Let me check. B1 C5. B1 is a king. C5 is a king. Both of them are fine. B1 C5 is fine. Then E6 and F3. E6 and F3. E6 and F3. E6 is a king. F3 is a king. So all 4 kings are fine. Okay. The next is queen. Queen should not be a problem because 4 of the 6 were already there. So I don't think queen will give us the answer, but let me still check out. D5, F6. D5 and F6. D5, F6. Both of them are queen, as I thought. Okay, these 2 are fine. E5, F3. F3 cannot be a queen. E5 and F3. E5 is not a queen and F3 is also not a queen. So 2 choices gone. So E5 and F3, these are incorrect. Okay, so I am left with the top 2 rows. Okay, so third is I need to look at E1, B3. E1 is a bishop. This is perfectly fine. B3. B3, is it number 3 or not? B3. B3 I don't know as yet, so I'll hold on. Okay. Then let me look at E6 and B4. E6 and B4 should be 4. E6 is not okay. E6 is 1. E6 is not 4. So E6 is wrong. That means correct answer is this one, right? So let me fill up. F3, F6, B3. F3, F6, B3. B3 should be 3. F3, F6 is 2. B3 will be 3. B3 will be 3. F3, F6, B3 is 3. B4 should be 4. B4, B6 should be 4, 5. B4, B6 should be 4, 5. B4 should be 4. B6 should be 5. And F4 should be 6. F4 should be 6. F4 should be 6. Wow, almost done. So 1, 2, 3, 4, 5. This one has to be 6. This one has to be 6 now. So what about the fifth column? So 1, 2, 3, 4, 5 is missing. So I'll put 5 here. Column row F, 1, 2, 3, 4, 5 is missing. So 5 comes here. Column 2, 1, 2, 3, 4, 5. We have a 6 out here. And column 3 will be 1, 2, 3, 4 is missing. Great. Done. Now 3 questions done. What's the 4th question? While moving horizontally from left to right, left or right, or vertically above, below, or diagonally, how many sequences of bishop knight exist on the board? Bishop was 3, knight was 4. So combination of 3, 4, either horizontally, vertically, or diagonally. So 3 and 4 combination we need to check out. So let me just, for ease of explanation, let me just, okay. So 3, 4, I am using a highlighter now. 1, 2, 3. 1, 2, 3. Okay, any other 3, 4, 3, 4, this is no, okay, 6, 5, okay, so 3, 4, and no other 3, 2, okay, 1, 3, 4, okay, 3, 4, I hope I have not missed any. Oh yes, this also 3, 4, so 1, 2, 3, 4, 5, 6, 7. The answer should be 7. Okay, so the critical thing which I want you to understand, that this kind of data set can be easily solved with the help of choices. I hope this tells you how to use choices in a Sudoku kind of a data set, and the same skill can be used, or same technique can be used in many other data sets in CAT. Okay. A travel company has operations in 12 locations, T1 to T12, spread in the state of Rajasthan. These 12 towns are vertices of a 12-sided regular polygon in the order T1 to T12. From each of these locations, one van carrying 10 tourists, which is its maximum capacity, departs in the morning at 8 am for each of the other locations and returns to the base at night. No other trips are scheduled other than the morning and night departures by the travel company. All the vans take the shortest route to the destinations. For example, to go from T3 to T6, you will take the road along the diagonal that connects the two of them directly. The travel between any two closest towns is 1 hour. The length of diagonal T1, T3 is 1.9 times length of T1, T2. Okay, so let me assume length of side T1, T2 to be 1 meter or 1 kilometer or whatever. So T1, T3 becomes 1.9 kilometers. Okay. Now first thing is, when I have a 12-sided polygon, to me it is the same as a circle. So wherever required, in order to approximate, I am going to use a circle in place of a polygon. Okay. So what is this figure like? So if I say this is, okay, so these will be the 12 towns. 1, opposite 1 will be 7, 1 plus 6, 7, okay, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. We know this T1, T2 is equal to 1 meter or 1 kilometer. Now look at this, the arc will be only slightly more, and which is why I said circumference of the circle will be slightly more than 12 kilometers, slightly more than 12 kilometers. If I am assuming T1, T2 to be, I am assuming T1, T2 to be 1 kilometer, that means the circumference of the circle will be slightly more than 12 kilometers. Okay. So I'll use it to approximate wherever required. Okay. Now, but I'm not going to do anything more than this now. All I know is that there are 12 towns, they are connected to each other directly. Okay. And it takes 1 hour to go from T1 to T2 and 1.9 hours from T1 to T3. Obviously, when you are going from T1 to T3, just for the sake of understanding, it is going to be a direct like this. This is 1 hour. This is T1, T3 will be 1.9 hours. So just as a understanding, this is 1 hour. This is going to be 1.9 hours. That means additionally 0.9 hours. What will be T1, T4? T1, T4 will be approximately 1 plus T1, T2 was 1 plus 0.9 plus 0.9 plus 90% of 0.9, which is 0.81. I am saying this is an approximation which I will be doing if required. Okay, so 1.9, 2.7. So approximately 2.7 hours it is going to take. So these are approximation which you can do in this kind of a data set. And remember, again I am repeating, a 12-sided polygon is almost the same as that of a is almost the same as a circle. Okay, great. So let's go to the questions. What is the maximum number of tourists that the travel company can service each day? Okay. Now let me look at only the morning departure. Only the morning departure is what I am looking at to begin with. If the departures are in the morning from let's say from town 1, you'll send vans to each of the remaining 11 towns, and each will have a capacity of 10. Okay. So if there's only one going from T1 to each of the 11, there will be one van going, and it has a capacity of 10. Now this will be true for each of the 12, so into 12. Okay, so 12 into 11 into 10, 132 into 10 is 1320. But this is happening in the morning. The vans will come back in the evening also, so another 1320 in the evening. So the answer should be 2640. Choice 4. Okay. So in this question there is a tendency to miss out possibly the evening's departure also, and which is why you should be clear. Van goes in the morning, it will carry few people, and when it comes back in the evening, it will again carry some people. Okay. Okay. So 2640 is the answer, question 1. There was a famous Dashara itself in the 3 towns T3, T6 and T8. All tourists headed to only these towns. There are 3 vans where ferry tourists from each of the location to these towns each morning. What is the maximum number of tourists the travel company could have applied to the Utsav at T3 and T6 from each of the 12 locations in the morning? So let me look at T3 first, because whatever is true for T3 will be true for T6 also, so I will multiply it with 2. As far as T3 is concerned, it will have 11 vans coming, or it will have vans coming from 11 other towns. Each of them will get 3 vans, right? And so that is 33 vans, and each has a capacity of 10. Okay, so this is going to be 11 into 3, 33 into 10, 330. So T3 will receive a maximum of 330 tourists from these towns. Okay, and what will be the case for T6? It will also be the same. So 330 plus 330, 660. Okay. One day, out of the 11 vans stationed at T3, 6 break down, and the mechanic proposes to repair it by 11 am. Okay. The travel company adds more trips to the vans idling at T3 to clear the backlog from the time, ensuring that there is minimum late arrivals at the destination overall. Which of the following is true if every van covers the journey at the same speed? Okay. So which are the vans which will be used? The van which will come from T2 to T1 can be used. So our vans start at 8 am. So T2 to T1, the van will reach at 9 am, and this will also be true for vans from T12 to T1, right? Similarly, if you look at T3 and T11, these vans will also come to T1, and they will not come at 9 am, they will come after. Remember what the question said, 1.9 hours. Yeah, 1.9 kilometers. So if I say this is 1 kilometer, okay, so if this is 1 hour, this is 1.9 times, so that should take 1.9 hours. Okay, so this will take 1.9 hours. 1.9 hours is 10:54. 1.9 hours is what it will take. So it will start at 8 am, reach T1 at after 1.9 hours, so 9:54. 9 hours and 54 minutes. So how many vans have broken down? 6 vans have broken down in all. So if 6 vans have broken down, we need to have 6 extra vans. 2 vans will come from T1, T12, 2 will come from T3, T11, and the rest 2 vans will come from T4 and T10. The closest vans is what we are looking at. Now, how much time will it take for this journey, T4 to T1? As I said earlier, T1, T2 is 1 hour, T1, T3 is 1 plus 0.9 hours. Okay. So my approximation says T1, T4 should be 1 plus 90% of 1 is 0.9 plus 90% of 0.9 is 0.81. So this will be 2.7 hours. So this will reach, these two vans will reach T1 at 2.7 hours is 2.7, 7 6 are 42. So they will reach at 10:42. Right? Approximately, it could be a little off, but by and large, I'm saying T4, T10, these two vans from T4, T10 will reach T1 at 10:42, and then the remaining two trips can be made. So 10:42 by 10:42. Okay, all tourists delayed at T3 will be cleared by 9:45. No, it will be earliest as per my calculation 10:42. 10 a.m. is wrong. 10:45 okay. 11 is incorrect. So among the choices, I will go with 3. Okay. Remember, it is an approximation I have done, but I can do this comfortably for the simple reason that the ratios will not change significantly. Okay, now let's look at the additional information. Suppose the 12 places are divided into 4 distinct groups G1, G2, G3, G4 having 4, 3, 3, 2 places respectively as per the location they are situated in. G1 consists of T1, T2, T3, T4. Further, suppose the direct routes are allowed only between 2 places satisfying one of the following. Okay, so there are conditions given. Let's see what the questions say. The number of vans operating on the direct routes. If one van departs one location on each of the direct routes. So the number of vans or number of trips is what we need to calculate based on the conditions given. Okay, this should not be a problem. If the towns T8, 9, 10 form G3, which of the following is the nearest expected arrival time at T9 for someone who starts from T2? From T2 to T9, how much time will it take? So this will have some calculation. If there are departures every hour till 12 a.m. starting at 8 a.m. on the direct routes at G3. Okay. Okay, let me, since question 5 says G3 is T8, 9, 10, let me put 8, 9, 10 in G3. So let me start putting this G1, G2, G3, G4. They have to have 4, 3, 3, 2 cities. G8, 9, 8, 9, 10 I am putting in G3 as per the fifth question. G1, we already know, let me just correct this, yeah. It says is T1, 2, 3, 4, 1, 2, 3, 4. So let me say 5, 6, 7, 8, 9, 10, 11 and 12. Okay. So question number 4 said how many trips will be there, how many vans will be required on direct routes. Okay. If one van departs for one location on each of the direct routes, okay, at 8 a.m. So both places are in the same group. If both places are in the same group, in G1 how many will I have? There will be 3 trips from 1. There will be 3 from 2, 3 from 3 and 3 from 4. 1, 2, 1, 3, 1, 4. Similarly 2, 1, 2, 3 and 2, 4. So 3 into 4, 12. What about G2? Direct trips as per condition 1. Again 3 into 2, 6. G3 will also be 6. And G4 will be 2. 26 trips. T1, T2 to any place in G2. From T1 to G2. T1 to G2 will be 3 into 2, 6 trips. From 1, I will have 1 to 5, 1 to 6 and 1 to 7 and the reverse trips will also be there. 5 to 1, 6 to 1 and 7 to 1. So 3 plus 3, 6. T1 to G2, any town will be 6 trips and vice versa. And similarly T2 to any town in G2 will again be 6 trips. So 12, 38. T3 to any place in G3. T3 to any place in G3 again 6 trips. And T4 to any place in G4. So T4 to any place in G4. There are 2 towns, so 2 into 2, 4. How much does it become? 38 and 10, 48 trips. Okay. If T8, 9, 10, then which of the following is the nearest expected arrival time at T9 for someone who starts from T2? Okay, let me just again, for my understanding, 1, 7, 4, 10, 11, 12, 2, 3 and we have to go to 7, 8, 9. So you have to go from Someone starts from T2 and he has to go to T9. How will you go from T2 to T9? T2 to T9. T2 to T9, you can go from T2 to any place in G2. So T3 to, okay, T3 to any place. So you'll have to do T3 to T9. So it'll have to be T3 to T9. Okay, T3 to T9 means I need to know the diameter of the circle. Okay, T3 to T9. So T2 to T9, T2 to T3 and T3 to T9. So this is going to be 1 hour in any case. So if he starts at 8 am, okay. Now as I said earlier, for me this polygon is a circle. So I'll say 2 pi r, it should be equal to, or let me say pi d. Let me take it as pi d directly. Na? Pi into d is equal to circumference is 12, or let me say pi d should be slightly more than 12. So diameter should be 12 upon pi, so 12 upon 22 into 7. Okay, 2 6 are 12, 2 11s are 42 by 11. 42 by 11 is 3, 11 3s are 33, 7, 8, 9. So 3.8 approximately. 33, 7, 8, 9. Yeah, approximately 3.8. I hope I've got it right. 11 3s are 33, 33, 3, 9 by 11. Yeah, 9 by 11, 11 3s are 30. Yeah, so answer is, yeah. So this is going to take approximately 3.9 hours or 3.8 hours. So answer should be 1 hour. So from T2 starts at 8 am, reaches T3 at 9 am, takes the bus from or van from T3 to T9, and that will take another 3.8 hours, slightly more than 3.8 hours actually. So 3.8 hours means 9, 3, 12, 8.8, 12:48. So it should be somewhat a little after 12:48. Choice 4. Okay. I hope this tells you how useful it is to consider a polygon with large number of sides as a circle. It reduces your calculation effort significantly.